All right, so yesterday we talked about the sum of the angles in a triangle, which what would a triangle add up to? 180. And we talked about this special theorem, the exterior angle theorem. Now, on number one, I don't actually really need the theorem necessarily. I could also do this, where I have a line created here. So I do know that this interior angle, that angle inside my triangle, would be how many degrees? 96 degrees. Okay, so this angle here would be 96 degrees. So one option is to just say that 2x subtract 2, this is this angle, is the 4x plus 20. This is this angle, 2x minus 2. So 2x minus 2 plus 4x plus 20 plus 96 has to add up to 180. Okay, that's one option on how I could set this up. So this angle plus this angle plus this angle, I know that within this triangle, it has to add up to 180. Another option that I have, if this is 96, then does it make sense that what remains in the triangle between this angle and this angle is 84 degrees? Okay, so the other thing that we can do, this is what our exterior angle theorem is we could say these two angles have to add up to this. Okay, that's because angle 84 degrees and 96 is a linear pair, adds up to 180. Okay, and this 96 with these guys have to add up to 180. So it's like a special theorem that I don't necessarily have to do that. I could also say that this interior angle plus this interior angle equals my exterior angle. Okay, so I kind of have two options. Whichever way I go, I'm going to end up like here. I could subtract 96 first before I even start, and I'm down to there. Okay, whichever way I go, I'm going to get the same answer. Sometimes we have to use this theorem where we know this exterior angle equals the sum of my interior. Here we don't have to, we have more than one choice. So I have 6 x's all together, and 20 and negative 2 gives me 18 equals 84. And subtracting 18, where is that going to bring me? 6x equals 66, and divide by 6, and x equals 11. Oops. Okay. Same thing on number 2. I don't need to use the theorem here. I could say, well, if this is 125, then this angle right here would be how many degrees? What would that interior angle? Not 65, but 55, yeah. So on this one, I could find my inside angle and then add them all up to 180. Or what my theorem says is this exterior angle 125 equals the sum of my remote interior angles. Okay, that this angle plus this angle has to add up to 125. But again, I could have done triangle equals 180 here too. Sorry, I'm having like a heartburn or issue. I can't really breathe very well right now. Doing my best. So then I have 18x and 13x is going to give me how many x altogether? 31x. And I have 3 and negative 2, so that gives me 1 altogether. Subtract 1. And I have 124 equals 31x. Divide by 31. How many times does 31 go into 124? 4. 4, yeah. Somebody out there on the internet told us. 4. Chance, we have, these are unit 4 warm-ups. I think you got them last week at some point, or did I give them to you yesterday? No, I gave them to you last week, I think. So see if you have them. It's warm-ups, homework number 19, and then the unit 4 packet. Now, when I get to 3 and 4, I have to know the theorem. Okay, my other option, I guess, is I could say that this angle is 180 subtract 8x plus 14. Okay, but that possibly we'd have to distribute. There could be whole lot of ways that we could go wrong here. Okay, the reason we have to use the exterior angle theorem here is because I don't know this angle, so there's no way I can find this one to add up to 180. And I don't know this angle, so I can't just use the linear pair. So I have to use my theorem that says that this exterior angle, 8x plus 14, equals my two remote interior angles, 56 plus 3x plus 18. Okay, this angle plus that angle. My exterior angle equals the sum of my two remote interior angles. Remote meaning it's not this angle here that's attached to it. Or 8x plus 14 equals 3x plus, let's see, 6674. Adding like terms there. And I subtract 3x. And I get 5x plus 14 equals 74. Subtract 14, 5x equals 60. And x equals 12. Okay, so, but I need to know that theorem to properly set that up. Why don't you try setting up the last one if you hadn't already? Okay, so how would you set up number 4 using that theorem? Did you find it? So my setup on 4, you should have, here's my exterior angle. So 19x plus 10 has to equal the sum of my interior angle. So 8x minus 5 plus 92. Okay, this angle plus this angle. Combining like terms, so 19x plus 10 equals 8x plus, this is negative 5 and positive 92, so it's going to bring us to 87. Subtract 8x. 11x plus 10 equals 87. Subtract 10. 11x equals 77, and you should have had x equals 7 on number 4. Okay, so that exterior angle theorem. Find homework 19. So you should have submitted homework 19 for today. You did evens one day and odds the next. So I'm just going to go over the odds, and then we'll continue in our notes. So what am I using on number 1? What do we know about a triangle? It has to, what? Don't all tell me at once. What does that have to add up to?
134.
What? What do you mean? Oh, this is 134?
Oh, yeah.
Okay. But the triangle has to add up to
180.
180. So if I have 80 degrees and 54 degrees, so I have 134 degrees, and I know that I have 180 degrees in my triangle. So if I subtract 134 from 180, that gives me 46. So that tells me that this angle here is 46 degrees, or that x plus 57 has to equal 46. And I subtract 57 and get negative 11 for my variable on 1. 3 is the only problem that uses what our warm-up was just on. So I have to do the exterior angle theorem here, where this exterior angle, 14 plus 17x, is equal to my two interior angles. Okay, so that should have been your setup on number 3. That was the trickiest one probably on the homework. So then you should get 14 plus 17x equals 6x plus 102, or 14 plus 11x equals 102, 11x equals 88, and x equals 8 is what you get on 3. Okay, so checking your own work, that was the trickiest one. 5 is not quite as tricky. I still can use this. So I still could have said that this exterior angle 70 equals these remote interior angles. So 4x plus 4 plus 12x plus 2. That's going to be a faster equation to solve. Or I could have also said, well, if that's 70, it creates a line and this is 110. And I still could have used that the triangle has to add up to 180, okay, which is just a more straightforward idea than knowing this theorem. So either way, whichever way you went, let's see, you would have gotten x equals 4 on number 5. Okay, it doesn't matter which way you set it up. I use the exterior angle, but even if you use the 110 and triangle adds up to 180, you still should get x equals 4. When we get to 7, it's a little more involved. So it's just triangle equals 180, but notice it says find the measure of angle A. So afterwards, we're going to go back and find the measure of angle A. And I know that x plus 82 plus x plus 63 plus 47 has to equal 180 degrees. So let's see. So that's going to give me 2x, 82, 63, 47. 192, yeah, is that what you got? That's 192 equals 180, or 2x equals -12 and x equals -6. So if you got here, great, but I still need to go back and find what angle A is. So if I plug in -6 plus 82, so that gives me 76 degrees for the measure of angle A. Okay, if I go back and substitute in -6 for x. Okay. On page 2 of your homework, we already did 8 and 9. 10 is still using triangle totals 180. So this is like a little puzzle problem. I have to start in this triangle. So I have 2 triangles here. This triangle, I know 2 out of 3 angles. So I can add those together, which gives me 105. And if that's 105 degrees, what must this angle be? 75. And then just to kind of move into my other triangle, what's this relationship here? Vertical angle. So if this is 75, then this is 75. Now I'm in the other triangle. So I go, well, 25 and 75 gives me 100, which means this missing angle must be 80 degrees. Okay, it's a little bit of a puzzle. You start with what you know and work your way over until you get to that missing piece. 11 through 14, it kind of switches the beginning of our notes. So you were not here on this day, so you would have to watch the video. Day 1 of unit 4, we labeled. This will also, by the way, be an open notes quiz at the end of this unit. So we want to make sure we're watching all of our notes and making sure they're complete. This would be a piece I would say should be like a freebie on the quiz where you're labeling. So in our first set of notes, it's posted in there if you haven't watched it yet. We talked about, well, we can classify our triangles by angle measure. So an acute, a right, or an obtuse triangle based on the angle measure. This is on the very first page of notes, page 2 in the packet. Or we can classify it by sides, equilateral, isosceles, scalene. So on the 2 that we have here, well, all of my angles are less than 90. So I would call 11 an acute triangle. And 2 of my sides are the same. So even though it's kind of drawn like they all are, we have to go by the measurements that they give us. So 7.8 and 7.8. If I have 2 the same, what is that called? What type of triangle? Equilateral, isosceles, or scalene? Two sides the same. Isosceles. Okay, so we call this an acute isosceles triangle. Number 13, all three sides are different. So this side is 7.2, this side is 7.8, and this side is 4.8. All of my angles are less than 90, so it's an acute. All of my sides are different. Scaling. Okay, labeling our triangle by angles and sides. Angles first, then sides. Okay. Okay, so we're going to do notes number 2 today, continuing with our triangles. Before we do that, actually, let's let's finish our notes. We didn't do the proof at the end of our notes last class, so this is on page 6 in our notes packet. So you can find this one proof. Okay, so we're given this proof. It says given this triangle ABC, and it says BD is parallel to AC. So BD is what we call an auxiliary line. So this line doesn't actually it's not a part of this triangle. They drew it in to show here's a line that's parallel to this side of my triangle. Okay, that's our first statement down here. So this should just be given. And then it tells us the next statement that's made is that 4 plus 2 plus 5 adds up to 180. Why is that? What do 4 and 2 and 5 create?
The triangle.
Well, it's not inside of here, it's here. So if I take angle 4 and then I take angle 2 and I take angle 5, it's given me a straight line. Okay, do you see that? So it's like a linear pair. We could say a straight line equals 180, that's fine. I have definition of a straight angle. You could also say definition of a linear pair, but it's not really a pair of angles. I'd take it though. Or a line equals 180, any reason that you can give to show that those have to add up to 180 because it's creating a line. Then it says, it gives me the reason. So it says if parallel, then alternate interior angles are congruent. So it must be using the parallel lines and alternate interior angles here. What would be an alternate interior angle pair that I have given this diagram? And I have 2 choices. I'm going to end up listing both of them. What's one alternate interior angle pair? Here are my parallel lines. So like 3 would be alternate interior with 5, yeah. So because I'm told these lines are parallel, because of this, then I can say that the measure of angle 3 is equal to the measure of angle 5, because if parallel, then alternate interior angles are congruent. Okay, so I know that 3 and 5 are the same angle measurement. I also know that 1 and 4 are the same angle measurement. Again, if parallel, then, oops, I don't need to dot there, alternate interior angles are congruent. Okay, so I'm using this for both 3 and 4. I know these lines are parallel. Here are some angle relationships that I have. So then, where there was 4 in that statement, they plugged in 1. Do you see that? And where there was 5 in that statement, they took this and they plugged in 3. So that shows us that 1 and 2 and 3 add up to 180. So we're proving that our triangle adds up to 180, given this diagram and the info we had. What did we do here? What's that called? We just We knew 3 and 5 were equal, so we plugged 3 in. We knew 1 and 4 were equal, so we plugged 1 in. What's that called when we plug in? But it starts with an S. Substitution. Okay. So to get to here, we just use substitution, and we prove that our angles in our triangle add up to 180. Okay, let's look at some other properties that exist in triangles. So the stuff we've talked about so far, the fact that a triangle adds up to 180, that stuff we've probably seen before. What we're going to talk about today is called the triangle inequalities. And so this is a theorem that we're going to assume to be true for all of our triangles. We're not going to prove it. We're just going to take our theorem. So it says the sum of any two side lengths of a triangle has to be greater than the third side length. Meaning if that's not true, if I had like little sticks and I was trying to make a triangle out of them, if two sides added together were less than the length of the third side, I wouldn't be able to form a triangle. Like it would give me something, I don't know, piece of chalk, like that or something. Like I wouldn't be able to make it work and fit together. And like even if I bent this down, it extends past it. Okay, that I can't make them all meet without either a gap or something going beyond that. Okay, so in order for three lengths to create a triangle where all of the endpoints meet at these vertex points, it needs to be true that A and B together is a greater length than C. That B and C together are a greater length than A. And A and C together have to be a greater length than B. So I have to check it kind of from each direction that that's true. Given three lengths, we can decide if something is a triangle or if it's not, okay? So on 7, I need to make sure that 3 and 5 is greater than 8. Is 3 and 5 greater than 8? No, they're what? They're equal to 8, right? But it's not an amount greater than 8. That's enough for me to just say, this can't be a triangle. Okay, that is not a triangle. I could keep going. The other sides work. 5 and 8 are greater than 3. 3 and 8 are greater than 5. Okay, but typically I start with the two smaller sides, right? Those always have to be greater than the largest side. That right there is going to tell me if it's a triangle or if it's not. If I'm going to say that it is a triangle though, like on 18, I do want you to list all of them just to show like I've checked this in from all sides and I agree that this is a triangle. So on 8, we agree that the first two sides, 11 and 15, is greater than 21. Yep. And the second and third side, 15 and 21, is that going to be greater than 11? Yep. And then my first and my third side, so 11 and 21, will that be greater than 15? Yep, works from all sides. This is yes, it's a triangle.
Wait, so, is it?
Yeah.
So it can only be a triangle if all of the sides are greater?
If it works from all different directions, right? So this one, sure, these work, but this one doesn't, so it's not a triangle, okay? So there's 4 underneath here where it says, tell whether the triangles can have these. So is this a triangle or is it not a triangle? You're either saying not or yes. Okay, I'm going to give you a moment to look at the next 4. Okay, meaning that there's a certain amount of, there's a smaller end and a larger end of values. We want to find the range that the third side could be to be able to create a triangle. And we're using the same inequalities as up above. So what I do is I call the third side x. So if I have a triangle and I have two sides, 20 and 13, and the third side is unknown right now, we're going to call it x. This is what I know needs to be true. That 20 and 13 together have to be greater than that side x, right? Any two sides have to be greater than the third. I also know that 13 plus x has to be greater than 20. And last, I know that 20 and x has to be greater than 13. Now what happens here is my range only has two values. It has bottom end and top end, okay? We don't need to consider all three cases. This one we need to worry about. We need to think here because 13 is less than 20. So I got to figure out what value would make this true. But on this last inequality, 20 is already greater than 13. Okay, so x could be negative and it would still work out just fine. Not that a side length would be negative. We don't ever need to look at this last case. This one we throw out, okay, because it's already, when I have the greater of the two sides that I'm given on the left compared to the smaller side on the right, this isn't one I need to look at, okay? So we know that there's, just like up above, three possibilities to look at. To find the range, I only need to look at these two. So 20 and 13, that gives me 33 is greater than x. So on this first one, we want to flip this around so that it reads in terms of x and not 33. So if I flip this around, it would be x has to be less than 33. Okay, that's my top value. It has to be less than 33, not equal to 33. Okay, less than 33 would make that inequality work. Notice that when I flip the sides, the sign flips with it, right? So the greater than became a less than as I rewrote it. You should be rewriting it so that the variable comes first always. So on the first inequality, I just had to add them together. What do I do for this inequality to solve for x? What can I do here to get x by itself? Just like an equation, I can subtract 13. So if I subtract 13 from both sides, that's going to tell me that x is greater than 20 subtract 13 gives me 7. There's my range. X has to be greater than 7 and less than 33. And if we want to get fancy with it, we can write it like this. X is between 7 to 33. X is greater than 7. X is less than 33. Here's my range written condensed. I'm okay if you have it separated, okay, but this is how we write it all together. Okay, X is between 7 and 33, greater than 7, less than 33. So same idea for the next one. So I'm going to call my third side X. These two sides have to be greater than the third side. What would be the other inequality I need to look at? So X plus what side has to be greater than what side? Which one do I need to look at?
23.
I think Stella's telling us. Yeah, X plus 23 has to be greater than 28. I know that I want to look at it this way because 23 is less than 28. So I got to figure out what value would I need to add to it to make this true. I do not have to look at this one. X plus 28 greater than 23. This is the one I don't need to look at because 28 is already greater than 23. Okay. So adding these together gives me 51 is greater than X. Or X has to be less than 51. Okay, there's my first value for my range. On the second inequality, subtracting 23, X has to be greater than 5. There's the lower end of my range. And if I were to write it together, X has to be less than 51, greater than 5. There's my range of values. Okay, so that's our big theorem with inequalities. There's another piece to triangles that we're going to add today. This one is usually grasped pretty quickly by students. So if you flip this, we'll see another, and this is not related to the first page of notes, okay? So in a triangle, okay, so here I'll use the one that's drawn up here, this 60, 30, 90. in my triangles, the way that a triangle is formed comes from the sides of the angle between the two sides that are meeting at that angle. And what happens, if you notice in my right triangle, the side across from 90 is always the longest length, okay? And we call it the hypotenuse in a right triangle. And you can kind of see, they drew this pretty well, okay, that the side across from 30 is the shortest length. This is the shortest, this is the longest, and then this is going to be the middle length. So what you notice with angles and sides is that given angles, I could order my sides from smallest to longest, shortest length to longest length. Or if I knew my sides, then I know which angle is the smallest, which angle is the middle length, and which angle is the largest. Okay, so the sides and the angles kind of have this relationship where we can order them from smallest to largest or vice versa. So if I had a triangle, do my best to draw it as accurately as possible, but I kind of messed up already. Let's see. So I'm going to say that this is 40, this is 60, and this is 80 degrees. And I'm going to call this triangle A, B, C. So here's triangle ABC. Now, it would be no big deal for me to ask you to order the angles from smallest to largest. What angle is the smallest?
40, C.
C, angle C. Which angle would be the next smallest or next largest, whatever, the one in the middle?
B.
B. And the angle that's the largest is A. Okay, so just looking at the diagram, I can order my angles. Now, what we are also now going to be able to do is we'll be able to order the sides from, and we'll go the same order, smallest, like lost in all there, to largest. So if I wanted to order my sides from smallest to largest, well, we said that angle C is the smallest angle. So here's my smallest angle. The side across from that, and the reason that it's the one across from that is that this angle is created from these two sides. So it's only going 40 degrees, and it's creating this length across from it that will be the shortest length, okay? So across from my smallest angle is going to be the shortest length. This length is AB. Okay, so AB is the shortest side. We said that B is the middle angle. And what side is across from that angle? That angle creates the length for that angle, open up to 60 degrees, is creating the length for which segment in my triangle? What do you think? 60 degrees, opening this side, and this side gives me this length, AC. Okay, so given that B is my next largest angle, that is giving me that length for AC. This is my middle length. My largest angle is A. Rotating those sides, giving you angle A. Across from it, BC would be the longest side. BC. Okay. So if I know my angles, then I can order my sides. If I know my sides, then I can order my angles. So on our triangle DEF, it says not the sides, it says write the angles from smallest to largest. So what length is which side of the triangle is the shortest side? Which side is the shortest side?
AB.
On here,
Oh,
on this triangle.
BD.
DE. So here's my shortest side. To find the smallest angle, it's going to be the angle that's, if I can think about it as the angle that's created that side. So angle F has rotated these two sides and given me this length. Or we can think about it as the angle across from the side that's given. So this is my shortest side that's coming from this being the smallest angle. Angle F would be the smallest angle, okay? Going smallest to largest. Sometimes it goes largest to smallest, by the way, so you want to make sure you read it. The next longest side would be 2. FE. What angle would I attach to this side? Would go to angle,
E.
which did you say?
FD.
Well, I want the angle. So this length is coming from this angle directly across from it, angle D. The longest length in this triangle is here. This longest length is coming from the angle across from it, angle E. Okay, so given sides, I can order my angles. Or given angles, I can order my sides. Now it only gave me 2 angles. Given 2 angles in a triangle, can I find the third? Yeah. Okay, so I'm going to give you a minute to do this last one. So first you got to figure out what's my missing angle. And then decide what side would be the shortest, which one would be the middle, and which one would be the longest side. And my missing angle, I would be 60 degrees. Which angle is the smallest? Not side, but which angle is the smallest? G. G is the smallest angle, which means the shortest side would be IH across from this angle. My shortest side is IH. Which angle would be the next largest angle? 60 degrees, angle I. And that means that the middle length of the triangle would be GH across from it. Which leaves me my largest angle, H, gives me my longest side of GI. Now, is it okay if I have like IG instead of GI? Yeah, that's fine. Okay, the segments can go either way. So if your letters are flipped around, that's fine, same difference. Okay, so now you have some time. So I'm going to give you kind of 2 suggestions of things that you could do. If you haven't watched any of the notes, so like Friday's notes, Evan, Friday's notes you may need to go back to. If you haven't done that, you could do that if you have headphones, because again, it's an open notes quiz and you want to have your resources, okay? If you want to spend your time doing homework number 20, then you can finish homework number 20. Tomorrow, we will meet over Zoom. I think what I will do is I'm gonna kind of call it an optional drop-in meeting. We're really just gonna go over the homework, okay? And then you have a checkout. So in terms of attendance tomorrow, if you don't show up to the meeting, then you need to pass in the checkout tomorrow in order to be accounted for the day, okay? That's up to you. I think it would be nice to go over the homework before doing your checkout, but you have all the resources you need to be able to complete that. Okay, so you can either get notes that you don't have, I'll finish homework number 20, the checkout's not in there yet, so you won't be able to do that until it releases tomorrow. I guess I could probably, I could print a hard copy if you want of the checkouts while you're working, if you want to get started on that and you finish early. Okay. Those of you online, I'm going to sign off.